So to conclude this series of lectures, so let's see what is the best and what is the worst of this or worst things of these naive based techniques. So let's see one by one. So first, the main thing is that our big assumptions, the primary and big assumptions for our naive based technique is it's our features, all the features of our, it is conditionally independence. So our all the features are conditionally independence. Independence of features. This is the primary first assumption. This is the basic assumptions. Okay, and this thing is true. If this thing, if our features are conditionally independent, if this thing is true, then our this naive based technique, our naive based technique performs dramatically well. Okay, we have seen this in theory. Just when we construct the naive based theorem from the Bayes theorem, we have seen this. We have taken the assumptions that all our features are conditionally independent. Okay, it's to the work. So simple from theory we have see this thing. And the main thing is, if this is false, if this thing, if our conditional independence is false, so naive Bayes, actually naive Bayes is reduces its performance. Is naive Bayes reduce its performance? This is the question. So some researchers shown that if you just search in your Google, so how the naive Bayes works on conditionally dependent features. So they have some research paper. It is not not so much important research, but some researchers have find that if our some features are dependent, then numerical then naive Bayes can works reasonable way, not good. I'm not saying that it is works very well, it is reasonable well, it can, if our some features are, if some features are dependent, if some features are sub, then naive Bayes works reasonable well. Okay, in reasonable well, it's work reasonably. Some research, if you're interested to how it is work, how it is some dependent features, how works on naive Bayes, just search it on Google, you can easily find. Just search it on Google, you can easily find this kind of research paper. Okay, so the main first big assumption is our conditions will be independent. Our conditional independence, all the features are conditional. This is the first primary assumption. Now the second assumption is, now the second thing is, so it is handle the high dimensional, it can easily handle the high dimensional data by simple using the probability, log probability. So we have seen this thing in text classification. We have seen the text classifications by simple emails, by simple use it in the email spam, and the email spam mail. So simple, so define email is spam or not, or simple review a data, review for a text review. So review the text So this is this kind of thing are simple high dimensional data. Okay, these things are high dimensional. So here we have seen that here naive Bayes are well dramatically for a high dimensional data. If we simple use the log probability, if we simple the use the log probability in naive Bayes, so it will it's baseline model for text classifications. We have seen that it is a baseline model. For another language, we see it is called a benchmark. It's a benchmark model for text classifications. Okay, this is the most second important thing. Now the third important thing is the for categorical features. For categorical features or sample for real valued features. We have seen this category how to handle the naive Bayes. When we have taken the example for naive Bayes theorem, we have seen the how to handle the categorical features for the naive Bayes technique. And as well as for real valued features, we have seen in the Gaussian naive Bayes, we are simple assume that we have taken the our real valued features are Gaussian distributed and simple finding its probability density functions. They are simply PDA. We can easily build the classifier Gaussians. Simple here we are using simple Gaussian naive Bayes. For binary classifier we are using the bernoulli naive Bayes. Bernoulli naive Bayes by simple taking the likelihood probability by simple. The likelihood probability is so by simple I have taken the here for this case our likelihood probability are Gaussian distributed or simple Bernoulli distributed or multinomial distributed. By simple see this thing in when you have so but the main question is that so in real valued features naive Bayes is not as good. Naive Bayes is not as good, but is it's depend on the situations any which domain you are applying this naive Bayes. Okay, so this depend on the situation to situations in which situations what distributions we have to apply. This is the main thing. Actually have to find the proper distributions for according to our problem, then naive Bayes is okay. Okay, so because of these reasons to finding the probability distributions, if you not find the proper probability distributions, then it is not a then naive Bayes is not a good algorithm. Now the fourth thing is that now the four most important thing is that its interpretability. Its interpretability and features importance. We have seen in medical applications. We have seen in medical applications, mainly in medical application. Okay, in mainly medical applications, we see that, and when we have taken a medical problem, we have to give the answer for a doctor or for a patient. Why this our model? Why this model interpreted such kind of to in such kind of situations? Naive Bayes is most useful. So most useful. You can because we can easily give the answer behind its why it interpreted. So the why the our query data gives this interpretability. You can easily by simple using the table of the likelihood probabilities by simple sorting this thing. Okay, and the and the main thing is that its complexity is so low. So it's if you just see its complexity, it is so low. So its runtime complexity, if you see its training time complexity as well, or if you see its runtime space complexity, so both all the things it is low, as well as it's low. So simple, we have to store what we have to actually we have to, for runtime space complexity, we have to store the class prior probability, and I have to store the only likelihood probability. So these two things we have to store, and we have see our prior probability is the number of C, and our likelihood probability is number of features, that is D. Simple, our run space type complexity is order of CD. So it is so, because of this thing, because of this low complexity, it is very useful. Okay, and one thing is that Napier base is simple a counting algorithm. We have simple just count our data features point. Napier is simple a counting algorithm. Because of its simplicity is so popular. Is simplicity and simple to implement. Because of these two main things, because of this thing, Napier base is so popular one. So I think we will understand its best cases why so popular Napier base. The first thing is it is conditionally independence. If your features are conditionally independence, then its Napier base are well dramatically well. And also we have seen there have some research, if our data are some features, if some features are dependent, then the Napier base works reasonable well, not good, but it will reasonable well. If you're interested, you can easily find it on Google. And so for high dimensional data sets, it is a benchmark or baseline model for mainly for text classifications, by simply using the log probability concept. And it is can easily handle the categorical features, and it is not if you just interpreted the real valued features, if you just find the proper distributions of the features, real valued features, then Napier base is dramatic well based algorithm. Okay, and the interpretability, to interpret it the something, so it's also good. Okay, so you can easily, by simple, you just simple finding the class likelihood probabilities, by simple see that we can easily find the features importance of it, which features is most important. By simple, it's seeing the probability, likelihood probability, we can easily see this kind of. Okay, and for mainly for medical applications, this is more useful thing for interpretability purpose. And I also see that it's runtime complexity, training time as well, and for runtime space complexities, because of very low, it's runtime complexity, training time complexity, and runtime space complexity, because of very low, so it is a benchmark for model for a high dimensional data. And we have to see how low space it is required for runtime only. So because of these reasons, Napier base is so popular till now. Okay,